All right, guys, how we doing? Welcome to the WPO 7 post 6C, excuse me, 6C. First of all, I'll show you the answer and let's get it. Vas-y, montre-moi ça. Okay, so the first exercise you have to use this formula. Then you will become, then you will have an answer like 4.8 and all the integers there. And the final answer will be this one. So you have to use this one. If you use 6.63, you will not have this answer, and you will maybe have this message as well. Okay, part B, part B is like this. So I just took my answer from part A. As you can see, 4.845 is literally mentioned here. You know, I just put it here and then I use this formula. And yeah, what can I say? You just have to do this and you will have your answer. Yeah, next one, next one, next one, next one. Okay, all right. This one is the second exercise. So let's get it. The first step, what you have to do is to collect some given information that you can see in this text and in this question. Qu'est-ce qu'il y a? Come, come. Ouais, j'arrive. Descends. I will talk a little faster because you need me. So yeah, first you have to do this kinetic max is equal to this one, and then you have to do that. So you choose the electron volt, and okay, it's equal to the Planck light speed of light, the wavelength, and we don't say work. So you have to do this, and then basically this is the first step. Then second step, then what I did here, just I will use this one. So I took this one and I divided to 1.60 times 10 with the exponent minus 19. Then you have the units there. It's just how do we say this? Joule per electron volt. Then I just drop some information what it means the C and the H and what this mean the wavelength, And then I did here? I just say that EV1 is equal to this because it was given, in the first situation. And then we get this. So if we get this, then finally we get this. But how do I have this one? I worded here like this one and this one. I put it here, in these two equation. So EV2 is like, yeah, like I show you. That's what we were finding. Finding it was E 1.9, and then we just have to need what is the potential in the second situation if they give us this, Okay, I hope you understand it. If not, drop a comment below. Let's get it. Ah. Okay, this one is the easy one, 12 exercise. I'll show you. So basically, they ask you to find the angle, and what you just have to do is you just have to know formula. This one. If you know this, then you can easily find the angle. Okay, let's go for the next one. Okay, here right now we are in the fourth exercise. Before before I will break it down this exercise, I will just say that this exercise is very difficult. I mean, not very difficult, but just you have to do a lot of work for writing. Well, okay, it's good. So on this equation that you see there, what I did is just I took the first term, so the h over my wavelength. This we call this it was the momentum of photon. This one was more for electron, but the story is going like this. So a photon is reaching an electron. I mean, an electron is like this. Imagine an electron is a circle. Then when it reach this electron, it will going backwards. It means that the photon is going away. It's just bouncing to the electron. So it's going there in this direction, and then yeah, it's going entering collision with the electron, and then it's going to doing the reverse. So that's why also I use the minus so to indicate how the photon was moving, or how the photon was evolving, you know, how it was moving, the motion of it. Yeah. So first that, and then this direction. Hope you understand it. And then you have the PE. PE is just the momentum of the electron, because this is just in the second situation, and this was in the first situation. Then I calculate like this. I just put my I also add my glider speed, because it makes it easier, and also we are talking about the kinetic of energy. They're asking what the kinetic of energy is of the electron, so we need also energy, not only the momentum, but the energy is also uh elevate. Damn, le mot là c'est très difficile à prononcer. Elevated. So okay. Then we have this second step. This one just show you the energy of my photon. This one also, this one also, this one also, and this is just the electron energy of electron. You can see and see like this also. So what I did is just you have to know that this one is just one equation, and this is another one, but apart. This one, this one is just another one equation. So what I try to say is just I add my energy there just to make it easier also, and also because it doesn't make it easier. And also I put this like this. So basically what you see here is just this one. When this one is going in the other side, it will be 2 times h times c over wavelength. So you will have 2 times the same things there. If this is no more in the right side, then I just add this one. It gives me then 3 uh, uh h times c, h constant of Planck, c light of speed. And then yeah, so basically you can see what I did. And then this one, I put this also on the other side, and you will see that this one is going to be negative, and just make the sum, and you will have 2 times h c over wavelength. And of course, these two stay on the same side, E0 and plus E. Basically, just look what I did, you know. So what I did was just also it's interesting to talk about this, because when I got this one, I put this in this exponent tool for more easily to know what it is, for what you can easily can search the energy about the final energy and the rest energy, or the rest energy, we can say this. So basically, that's a merkwaardig product, and you can say that you can put this in this formula, x tweede plus 2 x b, and then if plus the thing what I mean, plus c squared, Okay, so that's what we get. So first you have this one, then you have this one, then minus the 2 times E that you already know, and then plus my E if the correspondence. That is, it will be equal to my my energy of my electron. So here I just choose for my my final energy. It will give this one. It's a long part. Sorry, it's a long part. Okay. Now part 2 for the exercise. Okay, right now we are in the part 2, what I'm saying? So in this part 2, what I did is just, so the goal is just obviously we have to look for the kinetic energy of the electron. So I use my E that I found here, I just put this here. So basically it's the same as my right side equation. Then I use also this one, and this one I took it from this term, and after that I just did like this. So it's basically calculated, final energy with your initial energy. Yeah, I think it is. You got a question, ask me this in the comments. Okay, for the easiest way, I will break down in this way. Part B, I'm sorry, part B. So, will be what you have to say. You have to know the situation. We have, we have this photon and we have this electron here, and that is just my beginning of my beginning wavelength, So I think I took this equation just to find my new wavelength. I mean the wavelength when my photon will bouncing to the left side, So it will going like this and then like this, Then you will find this as your answer for this, okay? Okay, that's part A. Let's get it. Okay, everyone. Right now we are in the fifth exercise. So what you have to do first is just take this one. Wait, where's my pencil? Okay, this one. And then you have to search the kinetic energy. When you have this one, then you have I forgot to click on submit. And we have this one. You also have to do that 2 times. I mean, you have to do that for the electron and for the positron. Basically, they have the same kinetic energy because they have the same mass and the same momentum. That's why if they have the same mass and just momentum, they have the same energy, kinetic energy. Sorry, kinetic energy. Okay, let's go for the 60 exercise. You got question, drop it but always on the comment. Okay, right now we are in the sixth exercise. What you need to do, or what you need to have, of what was your first step that you have to do here? You just have to use first this formula, you know, this this formula. Mhm. Why? Because first you see already this, you know. Where did I look? Where did I find this? Where did I know here this, you know? Then you drop this, you know. And then you have also give information that visible light, you know, visible light. It's 180 degrees. It means that you can see that the photon is going to touch the electron, and then it will remove, you know. And when it removes, you can already see there is a light that's gonna be here, you know. Okay, then you see that there is a wavelength under. What you just have to do is to make it equal to each other, like I did with the color part, purple color. Okay. Then it was, I don't know if it's correct, but I think it will be, it's correct. No, it's not correct. I forgot to put, damn, I was too fast. But I forgot to put this because it was a long equation in my machine, in my calculator. But yeah, don't forget to put this in your machine, your calculator. Then you have this one. Damn, I'm going to do this one too. Give me 1 second. Give me 5 seconds. Which fair. 0.12, 12 times 10 exponent minus 9. Okay, I hope it will be corrected. Okay, otherwise I'm a clone, you know what I'm saying? Okay, let's get it. Okay. Okay. Oh, there. It's correct. Huh? Okay, let's get it for the next one. Okay, finally we're in the last exercise. So the last exercise is just have to use this one. In this situation, my kinetic energy is 0 because we first observed, you know. Then we have to use this. What I did is just using this one, but be careful because we want to know what it is for EV. So you have to divide it by 1.60 times 10 with the exponent minus 19 euro per electron volt, you know. Then we will have this one, and you have to, this one, and you have to write this, you know. Okay, second part B. Part B, okay. You have to use, so basically we have to search this one. Please, oh damn, I forgot to, but no matter. So V0 is equal to kinetic energy divided by the electron. Okay, but you have to first to look at here. So it's it's also the same here. So we already know that this one is equal to this one. So what we have to do is just kinetic energy, and we have to do like this. Then this one is just this thing there, you know, and this thing there is just here. And the total, you will have this one. And then you have this one. I think it will be corrected. Okay, it's corrected. Okay, that's what it's my exercise for repeal 7.